for coming. I see that we are now streaming to Facebook. Facebook viewers, thank you for logging on and for your patience. And now I'm going to let Bridget do the introduction of this concept, and then I will get to introduce our amazing guests, and we'll keep it brief so we can get to Tristin.
Yeah, thank you again, everybody, for joining us with Conservation Conversations, and sorry about the technical issues. Also, welcome to Conservation Conversations. Kate and I had started this idea, right when we started working from home and coronavirus was becoming a big issue, of course. And so we kind of wanted to just get everybody together and reconnect everybody back to nature and just, learn something new once a week and find a new appreciation for the nature that's around us, or and what we should be protecting. Again, my name is Bridget Sanderson. I'm the Director of Environment Missouri. I'm based out of Kansas City, Missouri, and we're working to protect our clean air, our clean water, and our public lands. So, Kate, I will let you go ahead and take it away.
Happy World Oceans Month, everybody. We got to start with that. I'm Kate. I'm with Environment Maryland, based in Baltimore, and it is my honor to get to introduce our guest, Tristin McHugh, who is the North Coast Regional Manager and Restoration Programs Manager for Reef Check, California. Tristin received her Bachelor of Science in Marine Biology and Legal Studies from UC Santa Cruz. She then led a number of projects spanning the Pacific Northwest, all of which focused on kelp forest ecosystem dynamics and long-term monitoring. She then focused on how disturbances of varying frequency and magnitude impact kelp forest in California, and the transition from kelp to urchin-dominated states in the Aleutian Islands in Alaska. Now Tristin is involved in efforts to understand changes happening in the north coast of California by conducting underwater surveys with the Reef Check team and utilizing that information to work with managers and approach kelp forest restoration efforts. So Tristin, thank you so much for being here on this World Oceans Month.
And Great, thanks for having me.
Yes, thank you. And we're going to start with a question that sort of, I feel like in reading that bio out loud, I said a lot of things that I don't fully understand. And so I'm so excited to get to dive in to some of the amazing work that you're doing. So we feature on here conservation experts from different fields, and it's always fascinating to hear what got people interested in the work initially. And so would you mind just briefly describing your work with Reef Check California and then how you got into sort of this specific area of conservation?
Yeah, so thanks again for having me. I'm really happy to be here. I'm in Fort Bragg right now, for Fort Bragg, California, for those of you who don't know. How I got involved in this area and just more generally Reef Check. Like you said, my background, I went to UC Santa Cruz and I just started diving when I was an undergrad towards the end of my career there. And I actually worked with marine mammals for a little bit, and I just fell in love with diving. I loved everything about it. I loved being underwater, just immersed, feeling the pressure, hearing the clicks underwater, like everything about it I just fell in love with. And so pretty much as soon as I started, I got hooked, and I made it my life's mission to do everything possible to make that like my everyday. And so after I graduated, I worked for UC Santa Cruz as a field technician, where we went all over Monterey mostly, and down into Big Sur area, Central California. And then sea star wasting hit. There's this big onset where sea stars became diseased, we're losing limbs. And I was in the right place at the right time, where I was able to go and document as this was happening in some other places like Washington and Oregon. And that gave me this really broad perspective where I had only dove California waters. And now I was seeing more of the Eastern Pacific, and I started seeing tendencies of similarities and differences in kelp forests. And I was it just kept fast, like questions kept coming. And so I started my master's work a couple years later down at San Diego State, where I looked at if you remove algae, if you remove the trees, what shows up? What is it? Is it more trees? Is it nothing? Are they opportunistic? And so I looked at that in a couple places in California. And on top of that, I was able to go to the Aleutians and study the productivity of kelp. So how much carbon are they sequestering? Those sorts of questions. And in a system where urchin barrens had been persistent for over a decade, over 2 decades in some of those places, and much longer in others. And so then I started to think about the timing of the transition of the kelp forest to urchin barren. And so coincidentally, I think this is one of those like coincidence sorts of things, but after I finished my master's work, I moved up to Washington to be with my partner, and I walked through the front door, put my bags down, and then I saw a job posting for this job in Northern California, which again, coincidentally, was also undergoing a phase shift from kelp forests to urchin-dominated states. And so while that wasn't my original objective of getting involved, it's become my life, is understanding some of the mechanisms going on there and thinking about it in Northern California, where there's no research station. It's a very small community. It's a rural community. And so we're pretty much the only dive group here locally looking at some of these phenomena. So that's a little bit about my background and what led me to Reef Check.
That's so wonderful. I love that so much because I actually went to my undergrad at San Diego State and I saw that.
Nice.
Yay, SDSU.
Yay.
So of course, with the nature of your job, you've traveled all over for your work, and I'm just curious, do you have a favorite spot that you love to dive?
That's always such a hard one, you know, because I would honestly say probably Big Creek, Big Sur, I think would be my favorite spot of all time for, it's kind of where I started my dive career, and most recently I saw a great white shark there. That was pretty cool. Yeah, it just always continues to impress me, and it's a University of California reserve, so it's a pretty special dive spot that is such a treat to go see and is so just remote outside of any place that you've seen. So I just love it. That's my favorite spot for sure.
I am from the mountains and have never, I tried to dive once and freaked out, couldn't do it. And so I love listening to you talk about it because it just sounds so amazing. And so our next question, Bridget and I sort of found you and Reef Check through an incredible video that you did where you sort of talked about kelp forests and algae and human history, and it was all brand new information to me. We would love if you could tell us more about the important role that algae has played in our history.
Yeah, you know, when I kind of started putting that presentation together, I was really wondering what direction to take it. And an avenue that I hadn't really thought about as much is, what are the origins? How did we kind of become disconnected from the resource to which we came here with? And algae is this, they are your rainforests of the sea, right? They're these places, these underwater just forests filled with fish and invertebrates and mammals and birds and insects, like all sorts of things live in kelp forests. It's incredible, and the diversity, especially along the Eastern Pacific where we are, is exceptional. And so it leads one to wonder, where do the resources lie, and how are we able to survive, or how are humans able to survive along this coastline? Because it's not the easiest place to live, but when you look at the ocean, you see the bounty, you see the life, you see the energy. And so one paper that I came across that really did blow my mind too was this concept that humans, rather than going across the Beringia land bridge and then going through the middle of America, Canada, and then now North America, right? Contrary to that thought, that was the pre-existing notion, was that's how humans kind of migrated through the Americas. And then there was recent archaeological finds to suggest that humans actually followed kelp. It was called this kelp highway. So if you think about it, if you look at the fringe, and actually, let me show you let me do this actually. Do I dare share my screen? Let's do that. Oh, host disabled participant screen sharing. We'll come back. But basically that you have North America, and if you followed all the way Alaska, or the Aleutian Archipelago, Alaska, Canada, dropping down to Washington, Oregon, California, down to Baja and further down, kelp is along that entire route, and again could support life in theory much more so than if you went all the way inland of the Americas. And so that was very new for me, and it blew my mind because it really just went back to this fundamental thought of why humans were able to be in these places that they were. And then the next question became like, what happened, right? Like what happened? And in Northern California, for example, along that kelp highway, there's a number of different things that happened, but the fur trade, right? Like after humans came down across that kelp highway, established, Russian fur traders, British, American, went back down that kelp highway, thousands of years later, and pretty much exterminated the otter population, which was a really key predator for the ecosystem. And then you had missions, and then you had cities, and then you had everything else happening after that. And as a native Californian, I've grown up here, and I didn't know that. And it's disturbing that I didn't know that. That I didn't know, that was never part of my history to learn why California was that place that everyone went, and it really is the kelp. And with the otter missing, with that trophic cascade totally shifted and totally mixed up, we're now in a place like in 2020 where things are starting to change rapidly, and the ecosystem is no longer able to withstand some of the other environmental stressors. And so that's really the crux of where we're at right now, which is trying to understand what pushes the state from a urchin or a kelp dominated state into something else, because we're seeing something else. So that was kind of like a long ramble of all of that, but it's a pretty long story, and it's wildly interesting.
Yeah, that video and everything that you just talked about was just absolutely fantastic and brilliant for me. I worked in an archaeology lab for a while, so this was just also whole new information for me. I did want to say that I did promote you. I'm so sorry about that, to co-host. So you should be able to share your screen if you want to try really fast.
Haha, we're good. Let me just show that real quick. Is that good? Yeah, okay. So when I was talking about that kelp highway, right? So this was in this blue. Can you see my mouse? If I'm using it? No? Okay. So right here in the blue is the overland route that was, really thought to be the one that humans got into the Americas from. And then the red area is that kelp highway theory, and it's that alternate route, or a coastal route. And might I also mention that the Beringia land bridge coming through the middle of the Americas, that would be by foot. And the idea is that humans actually were seafaring people, and were able to, jump from place to place to place and work their way down the coast, subsisting off of the kelp and all that which it supported.
Wonderful. So I have another question for you, of course. So the term kelp forests may actually be new, me included, to a lot of people. Can you actually tell us what they are and why they are so critical to, ocean preservation efforts?
Yes, absolutely. And I'm going to go back to sharing my screen because I like photos. So kelp forests are some of the most productive ecosystems. And again, it's like they are your trees, and it's really hard to envision because it's underwater, right? But you can think about the processes being very similar, where from the bottom up, you have your grasses down here, you have your red algae, you have the things that encrust the bottom, and then you have one of my good friends, she calls the little algae at the bottom invertebrate condos. So you have like these little interstitial spaces where all these little critters hang out. And then what eats the little critters? Bigger critters. And so as you work your way up the food chain, you have us, and we're kind of that top-down force on this whole system. And so kelp forests are important not only for, you know, critters, right? Like we love the critters in the ocean, but they do a number of things for humans too, which is typically where we focus our energy when we talk about some of these resources sometimes, outside of just aesthetic appeal of those places. But more generally, just like trees on land, they sequester carbon, they convert carbon dioxide to oxygen, they alter sediment flow. So if you think about coastal erosion, think about, if you're like a visual person, what happens when you go and stand on a cliff and there's a gale force wind and it's just like a grassy knoll? You feel it right on, right? What if you were still on that cliff, but there was a row of trees and hedges? Would you still feel that gale force wind? Not as much. So it's like, if you think about the ocean and those sorts of same processes, they do very similar things. But one thing that's very different about a kelp forest versus terrestrial place is how seasonal it is. So kelp forests go through these seasonal changes. So when light becomes available, when the springtime winds kick up and upwelling happens, so you have those cold, nutrient-rich waters coming from deep, kind of jump-starting that growth time. It's like time to go. It's this synchronous, like annual sort of process, and the year-to-year variation is really high, much more so than on land, because you could expect to walk through a grove of trees year after year after year, unless something like a wildfire happened. And so in the ocean, waves happen in the winter, and so it comes and rips out that very delicate kelp. It's very soft and malleable. So I guess where I'm trying to get at with this is, although they have a lot of similarities, they are different. And so when you go to think about conservation and how to restore those places, it becomes a bit more difficult than like walking out into the forest. It's year by year, ocean temperatures are getting warmer, they're changing. And those little tiny changes can have really big impacts on the bottom of the food web to the top.
I was so into your answer that I forgot I was supposed to ask the next question. I was like, this is blowing my mind. That's incredible. And so you touched on this in what you were saying, but what does kelp forest restoration entail? And it protecting our oceans biodiversity, what is the relationship there and the kind of critical nature of the two?
So kelp forest restoration can mean a number of things, but I'm going to speak specifically to Northern California because that's where I'm working. But generally, kelp forest restoration means, for us, we have urchins now in the place of where kelp once stood. And urchins are these like locusts of the sea, and they're native. They're native to these waters, which is a very, very important thing to remember, that these aren't invasive species. They are native to these areas that are triggered when something is off. And we don't know what that off is necessarily, but we think it's a number of factors, such as warming waters, which in 2008, so we're kind of going back a little bit, 2008, kelp started declining like very slowly, and then 2013 hit in Northern California, or just in the Eastern Pacific in general, and sea star wasting, that hit. So you lost this very, 90% of sea stars went missing out of the system, and they play a really large functional role. And so with that, we also saw a recruitment of purple urchin, which are again native to the waters, but something said, hey, you got like time to move in towards shore. And they've been known to do that all over the world. There are case studies from you know, Japan and New Zealand and Alaska, all over the place, that something triggered them to move in, and that's what we saw here. But in such a large regional scale, like we saw hundreds and hundreds of miles of coastline, have these urchins move through and gradually graze through the entire forest. And so we're not just talking like eating. I'm gonna show some pictures. Can you see that? So they just like kind of came through the system and just ate everything in their way. And so the question then became like, what do you do now? You have this this native species to the area that's now gone out of whack because something triggered it to just respond in this way. And now it's the question of, do humans get involved? And that's what we're trying to assess right now, which is, are we helping or hurting? Are we helping the system by intervening with what's going on? Or do we need to get involved and facilitate a push from this urchin barren state back into a kelp dominated state? And so what we're looking at is, you know, the cost benefit of this, of our human intervention. Like, what does it cost? How many hours are we putting into this? Is it worth our effort? Or is the system naturally going to heal itself? Which that's the interesting piece, is some places in the world, they naturally heal themselves. Other places in the world, they've stayed as urchin barren states for centuries. You know, you have some in Japan reaching 80 years, and these urchins can go a very long time in this zombie state and actually reallocate their metabolism so that they can stay hunkered down and just like not move for decades. And so you have this like very, very hardy and variable response. And so that's why, like, looking at it from a local level and seeing how that pieces in with other places is really important to assess, like, again, the pros and cons of humans getting involved, because partially it's like we've been extracting resources from these systems, such as the otter, right? And then you have your top predators, which keep those other individuals in place. And that's kind of where we're at right now with conservation and how we choose to, or this next year of really looking at what restoration does here in Northern California.
Okay, so you've kind of touched on this as well a little bit throughout all of your answers, because of course climate change is, you know, affecting all sorts of parts of all of the earth. But can you tell us about how climate change and other environmental issues are impacting your work and reef and kelp forest restoration?
Yeah, so like I mentioned, a lot of the processes and thinking, I'm just thinking algae now. A lot of the processes in the oceans are triggered by certain temperature cues. And for example, in San Diego, it was found that at, I believe it was 17 degrees Celsius, nutrients became unavailable for algae to use at that temperature. And so it's like functionally gone from the system. So they're unable to use that nutrient, and then they die. And so as our oceans continue to warm and warm and warm, it becomes really difficult for algae to harness those nutrients out of the water. It also, as you change the temperature, the amount of oxygen that's able to actually stay in that system changes. So in colder systems, you're going to have a higher oxygen content than you would have in warm waters. And so, and then that, you know, mixed with acidifying waters and, you know, it's just all the things put together. So when I think climate change, I just think, you know, accelerated warming, introducing carbon into the system, all those processes. And so as that's all happening, the ecosystem is responding. And so underlying all of this is that very notion that something happened that triggered the onset of this happening. And I'll also go as far to say that in many systems, the destabilization of the kelp forest state was triggered by the loss of an apex predator, so something at the very top. So in this system, it's thought that sea stars were playing that functional role. However, we're not so sure anymore, but losing sea stars and otters really decreases the resilience of that system. And so when you lose both of those, that's when you have a problem. And it just makes it makes the house weaker when you lose when you lose the players. So that's kind of where climate change kind of comes in with all of this. Is it's not necessarily like the warming just in itself. It's also all the other pieces too, and those are like multiple stressors acting on the system all at once, which is what really triggered this to push so strongly from one state to the next. And now it's fixed in one state. And so the question becomes, how much effort is it going to take to push it back? Because if this year we get warm waters, it's going to be really difficult for that algae to grow. But if this year we get cold waters, it may not be so difficult of a push because the algae is in a way better place. So one thing you can think about as a human is, how do you behave when you have a constant fever, of when your internal body temperature is up 2 degrees every single day, right? That's what ocean animals are experiencing when they have that degree change of up to every single day. So that's kind of and think about like all the gray whales that washed up last year, that warming water, it's all connected. Everything that we're seeing right now is very connected to each other.
Bridget and I were talking the other day that I don't have air conditioning at the moment in Baltimore summer, and we had a conversation the other day about how I was like, I'm really sorry. I am not being as productive as normal. I'm so lethargic. So I obviously can't. I can understand a little bit maybe what they're going through. And it's something that really struck me from an earlier answer that's going to lead into our next question is the piece of, are we helping or hurting? And that seems like such a constant question in conservation in so many different fields. And I think that it's something that comes up in our work too, is, you know, making sure we're crafting policy that is helping and not having these unintended consequences for other parts of the environment. I immediately think of plastic bags and the fact that we were like, oh, let's stop cutting down trees and put all of our eggs in the plastic bag basket. So our next question is, you know, to that end, what is the relationship here then between our behavior and what we're doing and this restoration and protection? And so it's kind of a two-part question. One, I think the first part is, what are the things that you all are looking for? What are your kind of metrics for understanding the helping versus hurting? And then the second piece of it is, what can we as listeners do to maybe change something about our behavior to help in your work?
Yeah, so the first part of the question, then you might have to remind me of the second part, but I think the first part is, how do we kind of quantify the helping or hurting part? So if we went in, and what does restoration look like? So what we're doing, what Reef Check, the org I work for, we use volunteer citizen scientists to go in and monitor reefs all over the state. Like, we go in over 100 sites from San Diego all the way to Oregon, and we're trying to push in the Pacific Northwest. And that's our California program. And we have international chapters too that do coral restoration, and they monitor their coral reefs, and they do that all locally in-house. So we have like a Reef Check Australia, Reef Check Brunei, Reef Check Oman, Reef Check Italy, like all over the place we have a Reef Check program. And so in California, we got involved in this effort primarily because we were here and we were collecting this sort of environmental data anyways. And we were in the position here in the remote corner of California to get on the ground and do this quickly in real time. And we live in the community. So what I'm working on right now is kind of orchestrating this hand-in-hand approach between monitoring, which is like our focal point as an organization, and working with commercial red urchin fishermen who have been greatly impacted by the loss of red urchin in this system. And we got funding from the Ocean Protection Council to go in and hire the commercial divers to go in and physically remove purple urchins from 3 targeted locations in the waters out here, which is going to end up being roughly around 30 acres of area that gets restored, hopefully. And so, so I guess where I'm getting with that is, if I went in and sent commercial divers, I'm like, go clear the reef, and kelp showed up, great, that sounds awesome. Sounds like it worked. Or you know, and then all the other critters would soon come after. If we went in and we cleared out urchin and kelp didn't show up, that's when you're like, what gives? So did urchins come back in and start eating things? Was the ocean too warm? Like, what happened? Or you could have this like third scenario, and probably many other scenarios, but the third scenario that I'm thinking of is you clear the urchin and then an invasive species shows up. Or you have a situation where the urchins just keep coming back over and over and over. And so you end up having this like drop in the bucket sort of approach, that, or urchins keep recruiting to that specific place, and nothing you ever do will ever remove that high of a density of urchins. So there's a lot of different scenarios that this could fall under, which is why I think it's really interesting to really evaluate and take a step back, as much as we want to be part of this, to really think critically about our role in this system and how far we should go to manipulate it and push it into one state or the next. And then I guess the next part of that too is, let's say in the ideal situation, we do remove urchin, kelp and the rest of the ecosystem comes up. How resilient is that system? Is the warm water of next year just gonna take it all to hell again? Like what's gonna happen? So this is all like in progress, and it's, again, like the ocean is so variable year to year that we just need to keep really close tabs on what's going on, not only from the ecosystem perspective, but oceanographically as well. And so I think that's part one, the question. And then part two is like, what can you do, right? that's the part two. You can start becoming kind of, I know this is kind of like an abstract way of thinking about it, but everything that we do is connected. And so even when you make little movements, little motions in your life, they have a really big impact. So, you know, cutting down on, I know it's like those basic things you can do, but, you know, cutting down meat products, not driving as much, basically like that laundry list of things that we know are very important, because when we're talking about releasing carbon into the system, again, that's warming. What happens when you have a hot thermos and you close the lid and you shake it? Like what happens? The lid pops, right? Like that's force, that's heat, that's energy. And so that same sort of process happens on Earth, where those warming waters fuel these strong, intense storms. So again, like everything that we do has an impact. And so if you can think really critically about your emotions in this life and move forward with intention and have, you know, those really intimate moments with nature, get your kids outside, like literally go outside and just gain an appreciation for these beautiful places. And I think that's probably the biggest thing you can do, is just get out there and show kids like how important it is to move forward with intention and have a deep connection with the place that they live, and show it respect and incorporate it into our everyday lives. That's what we need to do.
Yeah, and I feel that deeply when it comes to citizen scientists as well. You know, like I went down the path of science for quite some time, and it was because we had a field trip in elementary school where we went and helped tag monarch butterflies. So it's just like, just those early, you know, experiences to nature just like really helps to show how important these spaces are. So I love that. We do have a question in the chat that, if that's okay for me to ask. Perfect. Okay, so what do you think of the green gravel approach to restoration, and would that apply to Northern California?
Ooh, great question. So green gravel, for those of you who are unfamiliar with that, it's basically utilizing rocks that have kelp on them, or kelp spores, and planting them in places that are devoid of kelp to kind of push that next, it's like seeding. It's like going and seeding a garden. It's the same idea. So remember, kelp and algae don't have roots, but they have holdfast. And so instead of like the algae being, you know, incorporated into the bottom of the ocean, they sit on rocks and they grow on top of rocks, right? So green gravel is basically taking that concept and you could apply it to the system. That's actually an avenue that we're looking at if the system, after we remove urchin, doesn't naturally show kelp showing up. That's our next move, is to go in and utilize something like green gravel to go ahead and, you know, facilitate the restoration process and kind of catalyze kelp to start growing.
I had never heard of the green gravel approach, but that makes a ton of sense.
Yeah, it's a new, that was a good question. That's a paper that came out this year, actually, Norway, I believe. And they found it to be successful there. And so that's kind of like the hot thing right now with kelp restoration, is like one of the methods. And so it's a really cool and really, it proved to be really effective and cost effective too. So, yeah.
And it sounds like that's another place where it's a balance between how can we help versus getting too involved. That's such a balance. I'm thinking about all these things so differently now based on what you're saying. And another question that I have is thinking through sort of some of the things you said of there's so many factors to your work of, like you were saying, we can clear the urchins, but did it get hot? Or, you know, we can clear the urchins, but there's another invasive species. And so I wonder if you know, looking historically, have there always sort of been these ebbs and flows and changes? And it appears, am I right in thinking that climate change is sort of making those changes less predictable and potentially worse? Or is the ocean kind of always in this constant state of change?
Of ebb and flow.
Yeah.
Yeah, so just like we have deforestation happening on land, that same thing is happening in the ocean. So we're having a problem right now where, you know, historically, it was an anomaly for a system to transition from kelp to urchin. It was kind of like, ooh, like what's happening there? Sometimes it bounces back, sometimes it would just stay as it is, but it wasn't noticed as in as large of a spatial scale as we've been seeing over the last few recent decades. And so that is what's so worrisome. And here in California too, you know, we in Monterey, for example, that system underwent a transition from a kelp forest state to an urchin dominated state like in the 60s, and then reversed back to a kelp forest state. And so that's called like the hysteresis effect. And so you could have kelp forest getting pushed one way or another. The issue then becomes, though, the resilience and, you know, how easy it is to flip backwards and forwards. And what's happening now especially is, again, that question of multiple stressors where, you know, going, you know, a few years back, you didn't have as warm of water in those systems. So some of those transitions were triggered by the loss of an apex predator. What we're seeing here now in 2020 is not only is it the loss of a predator, it's two predators. And then we also have like a warm blob happening. We also have El Nino happening. And then you have a number of different processes like urchin recruitment that's happening. And so those multiple stressors make it really difficult to pinpoint what exactly is causing this shift from one state to the next. And it greatly varies by place. And so that's why it's so important that even though this is happening all over the world, you have researchers in all these different places, you know, using things like green gravel, and it worked for them, but maybe green gravel doesn't work for us. And so it's really important that you do spend the time to understand local mechanisms and local changes, because California, for example, is like this one, you know, you think about California, you're just like, it's California, but there are these biogeographic breaks. It's a huge state. And so the ocean sees no boundaries, right? Like it doesn't see state lines. It doesn't know anything of invisible, right? Like borders are invisible to the ocean. And so it's really important to think about the ocean as like distinctive regions based on their biological and oceanographic composition. And so that's why it's so important that we assess some of those nitty gritty, like, is green gravel going to work here? Like those are really important to understand for here in Northern California.
Okay, so we do have another question. What does the red urchin cleanup look like? I think like you go out and just like shovel it out, because that feels like a big chunk of area pretty much that you're clearing out. So
yeah, so that's kind of where we're at right now, which is we are about to launch those efforts. I'm trying to find a photo that would kind of describe. Yeah, let me just share my screen. So these red urchin divers are going into these areas, and they're going to be vacuuming out, so harvesting urchin out of the water. And all over the world. So again, they're red urchin, they commercially target red urchin to sell, but purple urchins are the ones that we have like pervasively right now. And so they're gonna go in and remove purple urchin, which aren't their usual targeted species, but they're gonna use methods similar to the way that they harvest urchin regularly. And they're harvesting them, they're gonna put them in bags, they bring them to shore. We look at the gonad index, so like what do their innards look like, we weigh it. We look at bycatch, we look at like all those other things. So going to that helping or hurting part, right? We're gonna like look at some of those metrics and see what kind of comes out of these bags. And so that's how the urchin divers are gonna be harvesting. And I guess more generally too, we have like these targeted locations where actually tomorrow I'm going diving with a couple of my new divers, and we're gonna go and pilot and kind of map out the reefs that we're going to be targeting. And we're actually going to be deploying this benthic cable, this temporary line underwater. So we're going to use this underwater drill and basically drill these like really small holes and then put eye bolts. Give me 1 second. Pretty cool. I had it right here. So it's this like underwater drill. And it hooks up the same as you would on land. And this is like a really cool one that you don't need. It's an electric versus pneumatic, which means you would use like a scuba tank and then a bunch of cords to make it go. So this one, basically you drill the hole and then you put in a bolt, you use marine grade epoxy, and it just stays there. And then we're gonna put line in it and have it basically go across the reef so that urchin divers can clip in to a designated location, go in and clear it, and then from the monitoring side, we can assess how the ecosystem is responding at that scale. So if we see urchins in that spot, was it because the commercial divers like missed it, or was it because urchins just came out of like a crack? So those are some of the things that we're going to be looking at.
I want to be cognizant of your time. We've gone a little over, but one quick question that I have, just based on what you said, and this may be a really silly question, but for commercial divers who are collecting the red urchins, what are they for? Why is the demand so high?
Goonie, the innards of the urchin. It's a really hot market in Asian markets, and so it's a delicacy to a lot of folks, and not like Californians don't eat it as much. They kind of still, I'm not a big fan, like it does not taste good, but some people like love it. Like I've seen divers like crack them open underwater and eat them before. Like some people just like love them. So yeah, they're delicious in theory. I don't believe it, but.
Okay. So normally, I already asked this question earlier, which is what can we do to help, which you answered. And it sounds like potentially, you mentioned dietary choices earlier with climate change, but it sounds like also, should we be thinking through maybe not, oh, sorry about that, eating urchins, and then the other, I keep saying it's my last question, but I'm thinking about so much. I know that kelp is one thing and seaweed sort of another, but I think about like nori and things like that. Is human consumption impacting in that way too, or am I making a spurious correlation?
Yes and no. Actually, that's like a really hot thing right now, which is thinking about, algae. People are eating kelp all of a sudden. Like, I mean, it's been a prized food for many cultures for as long as they've been in existence, but all of a sudden, some folks are getting really more so interested in it now than ever before, because it's really good for you. It's a very sustainable food choice. I was just reading an article where it could be like if you feed it to cows, it could be used to reduce the amount of methane that they like basically blow out of their butts. So, it has like this number of different properties. And so I guess for like our impact on that system, there's always sustainable ways of doing things. So I'm thinking right now, up in Southeast Alaska, like they have kelp that they've been harvesting sustainably, like hand harvesting kelp. Like that's a thing people do. People do it here in California. Recreationally, folks harvest it. Is demand always going to be there? Yes, of course. But I think the question becomes, how can we start utilizing the things that are growing around us instead of having to import it? And why are we shipping our food? This is like a personal opinion now, like I'm kind of transferring here, but like, thinking about like carbon, when you think about like how much carbon it takes for your food to get to the grocery store, does it make more sense to just go out back and go collect some algae and munch on that, or like eat an urchin, than it would to go and buy like the steak from the store? Probably. And so I think just like reevaluating the way that we interact with our environment and eat the local foods around us and observe seasonality of foods is really important. And I think we should be like really cognizant of that delineation where like sustenance eating is real. Like we should rely on the things around us and be, again, cognizant of our local areas and what's available to us.
Sorry, my button quit working. My mouse. Tristin, this has been absolutely wonderful and completely fascinating and brilliant, quite honestly. This is all new information to me, having resided in the Midwest my entire life. So thank you so much for coming on Conservation Conversations. Thank you everybody else for watching with us as well and joining in on the questions and discussion portion. If you enjoy all the work that we're doing, please consider donating to Environment Maryland, Environment Missouri, and Reef Check California as well. Yeah, thank you so much, Tristin. Kate, do you have anything else?
No, I think I could leave like my contact info. You can find me on Reef Check's website if you have any follow-up questions or want to know more about our programs either in California or in other parts of the world. I'm available and you can find me on our website.
And we linked to Reef Check in our social media posts about this, and we put Reef Check's information in the email that you all got with the RSVP info. If you're on Facebook, just check the links where we link to Reef Check California. Check out their website. All of the work they do is amazing. And Tristin, thank you so much.
Thank you guys. Thank you so much.
Wonderful having you.
Thank you. Thanks, everyone.
All right.
Bye.